Today I start work on my game, Lamb Slam. Lamb Slam is going to be a heavily storyline based action game with some comedic elements sprinkled in there for good measure. It's going to be set during the apocalypse where genetically mutilated sheep roam the land and the player will fight these creatures off. I'm writing the game in Java using OpenGL for the graphics, and I will be documenting the whole process, starting with the setup you're seeing sped up right now. And the basic setup is done. At the moment it's just a simple 3D rendering system, but it gives me the ability to start work on some of the main features, then come back and revisit the graphics later in a big overhaul. I've also created a simple GUI system with some basic text rendering, but again, nothing too fancy there. The next thing I decided to work on is a little bit of terrain. As the game is going to be made of predefined levels, the terrain height will be defined using height maps. I've opted to do this in the vertex shader, so every terrain is rendered with the same mesh, a simple subdivided plane, but the height of each vertex is changed by sampling the height map texture in the shader. Achieving this is fairly simple. What is slightly more complicated is calculating the normals for the terrain surface. To do this, I've had to turn to calculus. That's quite dramatic. It's actually a lot simpler than it sounds. If the terrain was a surface defined by a single continuous function, to find the normal at a point we can just calculate partial derivatives. If the function is z equals f of x, y, then we can just calculate the partial derivative with respect to x to find a vector in the x direction, and with respect to y to find a vector in the y direction. To find the normal, we can just find the vector perpendicular to both these tangent vectors, which we can just use the cross product rule. This is basically the process to find the normals, but the terrain isn't a continuous function. So instead we have to approximate the derivatives by finding the gradient between the two neighbours on that axis. Once this is all implemented in code and put together, this creates some normals which can be used in the fragment shader for some basic diffuse lighting, the same as with the entities. Now, at the moment in the code, it's a bit of a mess as to how all the objects are stored and passed to the renderer. So I've created the concept of a scene. Each scene contains a list of all its entities, terrains, lights, the camera, and anything else that comes later down the line. Along with this, I've also created a way to load these scenes from a JSON file. This will make it so much easier for me to create the many scenes within this game, potentially piecing them together in a separate program, similar to creating a model in Blender and storing it in the game files as an OpenGL file. On a similar note, I've also created cutscenes. These allow for the animation of entities and the camera, and of course the player has no control over these. They also have a way to load from JSON files just like the scenes. That's all I've got for this one. If you have any ideas for improvements or additions, make sure to leave them in the comments. Thanks for watching.